Welcome back to the channel everyone. Today we'll discuss another problem from magnetism chapter, and I have picked up this problem from SBT volume 2 from magnetic effect of current chapter, question number 29 of level 2, right? So basically if I have to categorize this problem, this one tests your skills of scaling, right? How well can you understand these two situations and correlate between them? I mean, there will be one situation of some other elements. Okay, so first let me clarify that this one is just a brief. You may not understand nothing from this brief, but still not to worry, we'll discuss the solution in detail and you'll understand this problem. But yeah, I was saying that you have to relate to situations, right? In some situations we are not in position to determine every minute things or the inner mechanism, right? That at each point what is the value of magnetic field, what is the angle between magnetic field and some dl vector, what is the dot product. We are given some data of some given situation, and using that data we'll do some scale up or scale down by some factors, and we'll predict the result of some other situations as well using the help of that situation. So it's kind of a that problem, right? So okay, again, if you have not understand nothing till now, not to worry anything, we'll discuss the solution in very details, and I hope you'll understand at the end of the solution. So let me read out the problem once quickly. In the figure shown, W1 represents the cross section of an infinitely long wire carrying current I1 into the plane of the figure. AB is a line of length L, and wire W1 is symmetrically located with respect to the line. The line integral A to B of B dot dl along the line from A to B is equals to minus A naught. Obviously this one is when only the effect of W1 is taken in consideration, where A naught is positive number. Another long wire W2 is placed symmetrically with respect to AB, and the value of same line integral becomes 0. So when you take in consideration of both W1 and W2, this line integral turns out to be 0. And consider a line DC to the right of W2. The line is parallel to AB and has same length. You can see the figure below. The two wires fall on perpendicular bisector of both lines. If the line integral C to D of B dot dl is 2A naught, with both the wires W1 and W2 present, calculate the ratio of I2 upon I1. So this is the line integral of C to D, taking in the effects of both both the W1 and W2 wires. So let's move on to the solution. These are given datas. I have just written again. These are the two line integrals given. That B1 dot dl is minus A naught, where B1 is the magnetic field due to W1 only, and B2 dot dl, this line integral over A to B, is plus A naught, where B2 is magnetic field due to W2 only. So this thing is clear, I guess. And now with the help of these two datas, I'll calculate the line integrals over C to D due to wire 1 only and wire 2 only separately. Now let me show you how. So you just look at the figure. This one is the setup if we think about AB wire and W2 wire only, and forget the everything else. You just focus on AB wire and W2 wire. And now you again look at only W1 wire and CD line, right? Don't you think these two are almost similar situation? Maybe you are wondering about the directions of dot product because that will also matter, right? Some sign may change. But if you neglect for some time the directions, just if you think a scalar point from scalar point of view, does not these two things look similar, right? Because if you place a wire of same length AB here and place a wire of, let's say this is AB, and this one is some infinite wire carrying current I2 similar to W2, and you keep these two directions same, and obviously this is also on perpendicular line, I mean perpendicular bisector line, and if this distance is L, this distance is also L, and this distance is L. So anywhere you put this setup, actually the line integral will be same. This one is my claim, right? Obviously you need to have the same current as well, because I1 and I2 are also changing. That's why I said almost similar, not same. There will be some change due to the current factor, but we can manage that. So coming to this question, coming to the solution again, I was telling that for I2 and AB, now just think about the direction problem that we are facing. I told you to neglect for some time, but we have to figure out that also. So I'll just show you at one point that the direction for this case and this case got reversed. It is actually true for all the points over A to B and C to D, but I'll show you at one point just for the ease of solution. So for I2, you just determine the direction of magnetic field at this position, as I2 is pointing upwards. So it's clear that magnetic field, this one is the direction of B2 here, and we are moving in this direction. This one was the direction of AB. So B2 and AB were in same direction, same. But for I1 and C2, what is the case? We are moving in this direction, C to D. And as I1 is pointing downward, the magnetic field at this point, let's say B1, is in this direction. So this is basically opposite. So here it was same and here it was opposite. So first thing is that it was plus of something. Here we will put a minus sign. And obviously the magnitude will also not remain A naught. As I said, the current is changing. So at each point, as magnetic field, sorry, let me use another color. Yeah, that B is mu naught I upon 2 pi r for infinitely long wires. So at each point for these two setups, as I have said, I2 and AB, I mean this one, let me mark with highlighters, I2 and AB and I1 and CD, everything will be same. Everything means mu naught 2 pi r and dl length also, and angle was because there will be one cos theta term, right? If you do the dot product, only the I, which is a constant, that will change. So when you will perform the integration, you can keep I outside, then the rest of the integral value will remain same. So I has only changed from here, it was I2, sorry, let me use another color. Here it was I2 and here it was changed to I1. So we'll change it with a factor of I1 upon I2, right? You can understand by simple unitary formula that for I2 the line integral value was something, so for unit it will be something by I2, so for I1 it will be something by I2 times I1, right? I'm not writing very cleanly, but try to understand. Okay, so let me clear some things, otherwise it is looking very nasty. Okay, wait, yeah. Okay, so moving on to the next part of the solution, again we will relate this situation to this situation, right? Okay, so I was telling that you should relate with when I1 and CD, whatever be the setup or correlation you can call between I1 and CD, we can call the same relation is satisfied by I2 and AB as well. You can see that from the figure. And again, I am not explaining the directions. You just check at your own that the direction will also get reversed again. So for A to B line integral of B1 dot dl, there was a minus sign. So for C to D line integral of B2 dot dl will be plus, as I have not shown any sign here, because putting a plus sign or no sign is actually same. And again the current got scaled up from I1 to I2, so we'll multiply a factor of I2 upon I1, right? Initially we have calculated this integral for current value of I1, but now we are calculating this integral value for current value of I2, so we'll divide by I1 and multiply by I2. That's a very common idea, right? So now we are almost done with the solution. We have separately calculated the B1 line integral of B1 and B2 over C to D, and we are given the net line integral. Net means the line integral of b net. B net is basically b1 plus b2. So b1 plus b2 dot dl is given as 2a naught in question. So we'll just add these two terms, right? b1 dot dl c to d and b2 dot dl c to d. I've just put these values here because and equated it to 2a naught. So we are supposed to find I2 upon I1, right? So I have picked up a new variable I2 upon I1 as x. So this will be 1 minus x. A naught obviously gets cancelled. X minus 1 by x is 2. And this turns out to be a simple quadratic. You solve it and you will get two roots, 1 plus minus root 2. Obviously 1 minus root 2 is not possible as it is negative. But ratio of two currents I2 upon I1 should be positive 1. So our answer is 1 plus root 2. And that's all for this question, and I hope it's clear, right? Once you get to the idea of that scaling, it's pretty easy problem. But if you don't get it, you can pause the video and see that portion again. I hope you will get it, right? Thank you. That's all for today.